Take a beaker, fill it a little lower than the brim, put your finger inside the water level rises. Fill it up to the brim. Put your whole hand inside the water. The water flows out of the beaker. Why do you think this happens? Well, Archimedes, a Greek scientist, once noticed that the water in a bathtub overflowed when he stepped into it. He discovered the reason for which the water is being displaced when something is immersed into it. The principle subsequently was named after him and is called as the Archimedes Principle. This knowledge helped him to determine the purity of the gold in the crown made for the king. Now, we all know that when an object is fully or partially immersed in a fluid, it experiences an upward force which is called the buoyant force. Can you measure the upward or the buoyant force? Well, let us see by doing another activity. Take a piece of stone and tie it to one end of a spring balance. Suspend the stone by holding the balance or the string. Note the elongation of the string, reading of the spring balance due to the weight of the stone. Now, slowly dip the stone in the water in a container. Observe what happens. We see that the reading of the balance decreases as the stone is gradually lowered into the water. No further change is observed once the stone gets fully immersed in the water. This means that some force acts on the stone in an upward direction, which is called the buoyant force. What is the loss in weight? Say, weight of the stone before immersing in the water is 1.3 Newton, and weight of the stone after immersing in water is 0.7 Newton. So the loss in weight is 1.3 minus 0.7, which is equal to 0.6 Newton. This 0.6 Newton is the buoyant force. Let us try to understand this better by doing another activity. Take a beaker and fill it with 300 ml of water. Immerse a stone or any object in the water. Did the level of the water rise? Yes, we can see that the level now indicates 355 ml. This is the displaced water, which is equal to the volume of the object immersed. So, we can conclude that the stone, when immersed in water, experiences an upward force, which is equal to the amount of water displaced by it. Can you think what happens when the stone is partially immersed? This is the Archimedes Principle, which states that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Relative density. The density of a substance is given by density is equal to mass by volume, and its unit is kg per meter cube. We know that density of different substances are different. For example, the density of coal is 19,300 kg per meter cube, while that of water is 1000 kg per meter cube. The density of a sample of substance can help us determine its purity. This knowledge of Archimedes' principle helped him to determine the purity of gold in the crown made for the king. It is often convenient to express density of a substance in comparison with that of water. So, the relative density of a substance is the ratio of its density to that of water. Relative density is equal to density of a substance divided by the density of water. Can you think of some day-to-day application of Archimedes' principle around you?